Today we're going to have a look at the quotient rule. There are different ways that the formula can be written in different books and the likes. I'm going to start with what I think is the simpler way, which is definitely how I would recommend first learning the quotient rule. And it's quite similar in the notation to the product rule. So what we have here is, if we're talking about f dash of x, we have u dash v minus u v dash all over v squared. Okay, so when I was talking about the product rule, I did mention that you didn't need to be so fussy as to which term you called u and which one you called v, but with the quotient rule we need to be careful because of this negative sign in there and the likes, that when we do our rule, it's the numerator we call u and the denominator we call v. So without further ado, best way to learn is by example. So let's do one. Just move you over there for a second. So for example, if I have y equals 1 plus 3x all over x squared plus 1. So obviously the quotient rule, as the name suggests, we're talking about terms in two terms in a fraction. Step 1 is we call the numerator u, and step 2 is we call the denominator v. And then we find the derivative of each of those one at a time, and we call them u dash and v dash, just like the product rule. So u dash equals, in this case, 3, and v dash, in this case, 2x. Okay? So now we apply the formula. U dash v, so we go 3 times x squared plus 1. Now, can I strongly recommend that you do this next thing? When we do the next item, put the minus sign there and put it inside some brackets, some square brackets. Because that minus sign there, as you can imagine,
a few moments later.
Might be able to stitch them together. Welcome back. So once we've done all that, we can collect our like terms on the top. 3x squared minus 6x squared will be minus, whoops, back to the pen tool, minus 3x squared minus 2x plus 3 all over x squared plus 1 squared. And that's probably as far as we need to go for this example. There's quite often a student that goes, yeah, that's all well and good, but couldn't I just use the product rule and do the same thing? So what I'm talking about there is, let's go back to our original question. So we had y equals 1 plus 3x all over x squared plus 1. And a student might say, well, why can't I write that like this? 1 plus 3x in brackets times by x squared plus 1 to the minus 1. Why can't I write it like that and then do the product rule? And the answer is you can. In fact, the quotient rule is essentially doing that same calculation, just doing it in a nice, simple and more efficient way. It's essentially doing the same calculations. So you can absolutely use the product rule there and get the same answer, get the correct answer. But I don't recommend it, and I'll show you why. So let's do the product rule. So we're going to do u equals 1 plus 3x, u dash equals 3. We're going to do v, we're going to need a bit of chain rule here. So we're going to do v equals x squared plus 1 to the minus 1. V dash is going to be minus 1 or minus x squared plus 1 to the minus 2 times by 2x. So that equals minus 2x, x squared plus 1 to the minus 2. Okay, just a bit of chain rule there. Let me know if I've made a careless mistake. So let's put it together using our product rule, u dash v plus v dash u. So u dash v is going to be 3 times x squared plus 1 to the minus 1. Then when we go plus u v dash, we've got a minus sign here, so it's ultimately going to be minus 2x times 1 plus 3x times by x squared plus 1 to the minus 2. Now that looks different to the answer we had with the quotient rule, but it's essentially the same. Unless I've made a careless mistake in there somewhere, it's the same thing written differently. And if I wanted to tidy that up just a little bit, I could write it without the negative indices and say that's 3 over x squared plus 1 minus 2x 1 plus 3x all over x squared plus 1 all squared. So what we have there is we've got two fractions rather than the quotient rule gives us our answer and we've got one single fraction. If we do it using the product rule, it's 100% correct, it's the right answer. But now we've got two fractions. So the reason I don't recommend doing this is because there's an extra step that we now need to do. It might be a simple, it might be complex, but the next, with a more extensive question, generally the next thing we're looking for you to do is to work out what would give you 0 on the numerator or maybe 0 on the denominator, to work out when the gradient's equal to 0 or when it's undefined perhaps. So the next step generally needs you to combine both of those fractions into a single fraction in order to do it. So there's an extra step now involved. It's not a crazy long thing to have to do, just to find that the lowest common denominator is going to be x squared plus 1 all squared, of course, but it is extra time and a bit of mucking around, a chance to make a careless mistake. I don't recommend doing it. I recommend using the quotient rule.